So in part D of this question, we're told the sambar, another species of deer, is in similar size to the tool elk. And we're told the slope of the population regression line for this species is 4.5 kilograms per centimeter. We're told a wildlife biologist wants to determine whether the slope of the population regression line for the male tool elk is different than for the male. And we're letting beta represent the slope of the populations. And we have the following null and alternative hypotheses. The test statistic was calculated to be 3.408. We need to determine the p-value of this test. So what we need to say here is, well, firstly, we need to calculate the degrees of freedom. So since we have the degrees of freedom will simply be n minus 2. We have 30 to elk. So n, the degrees of freedom will be n minus 2, which is 28. So we're told we can go into the table for the t-values, and we need to look for 28 for degrees of freedom, for which we will get a p-value of 0.001. However, since this is a two-sided test, so we're comparing two means over here, we need to multiply this value by 2. So we multiply this by 2, so you get 0.02 for the actual p-value. And then in part 2, we're told at a significance level of 0.05, what conclusion can we make? So what we can say is that the p-value, 0.02, is less than 0.05, and therefore we reject the null hypothesis. Reject H0. So what that means is there's enough evidence to show that the slope for the regression line of weight versus chest circumference for the male tool elk is different from 4.5 kilograms. So the slope for male elk is not 4.5 kilograms per centimeter.